All right, in this video, we're going to talk about derivatives of inverse trigonometric functions. Our objectives will be to find derivatives involving inverse trigonometric functions, find higher order derivatives of functions involving inverse trigonometric functions. We use the product, quotient, and chain rules to find derivatives of functions involving inverse trigonometric functions. So let's go ahead and look at the three main trigonometric functions here that you're going to find derivatives of. We'll find derivatives of their cofunctions and other things in a second. So the ones that I want you to focus on right now are arc sine, arc tangent, and arc secant, because we'll focus on their cofunctions in just a second. I'm sorry I don't have completely blank notes for you here, but we're just going to work on the ones that are filled in here already. So what you want to see here is that arc sine here is only for x values that are between -1 and 1, because that's the range of the sine function. Should be allowed to get, I can't put -1 or 1 in there because that's going to make the denominator 0, and I don't want that. So same thing here for our cosine. And get there, notice that it's a cofunction, so it's going to have a negative in it, but everything else is the same. Tangent here is going to be 1 over 1 plus x squared. And you're going to see arc cotangent is going to be the same as arc tangent, but it's going to be a -1 instead. Arc secant, it's a little different. We're going to have an absolute value of x on the outside here for the derivative. It's 1 over the absolute value of x, since the square root of x squared minus 1. And arc cosecant, as you would imagine, is just like arc secant, but it's a negative there. This will make a lot more sense once we get to calculus 2, and we can kind of derivate some of these things with what we call trigonometric substitution. But until then, just memorize these, and I promise we will come back to these even more in our discussions in calculus 2. But for right now, we're going to just add these to our basic rules, our catalog of things, and we'll do some things where we need the chain rule for them. So let's go ahead and look at just if y was arc sine. This is one of our basic ones up there. Arc sine of x, then y prime is going to be 1 over the square root of 1 minus x squared. That's just one of the above formulas. Now, if we have y equals arc tangent of 2x to the 5th, we're going to have to let our u be 2x to the 5th. Our u prime is going to be 10x to the 4th. And so we're going to use the arctangent formula that says that it's going to be y prime will be u prime over 1 plus u squared. It's going to be 10x to the 4th over 1 plus 4x to the 10th. 10x to the 4th over 1 plus 4x to the 10th. All right, and I think those are the only examples that I have here, but this is just a section with a lot of memorization, not a lot of examples to do. Try some of the textbook problems on your own, and I'll have some additional supplemental examples that I'll put up later. But focus on this section in particular with memorizing these these 6 rules, but especially the 3 rules that I put stars next to because they're co-functions here are just going to be negatives of the ones that are not co-functions. So memorizing the first 3 basically gives you the other 3 that are just negatives of them. And because of that, when we get to some stuff later in Calculus 2, we're only going to focus on these 3 rules because we don't want the ones with the negatives in them. All right, that's it for this video. And we'll come back next time and we'll talk about implicit differentiation and related rates. See you for the next video.